Okay, so the convolution theorem. So if you have one time function and you take the convolution product with another function, the Fourier transform is the Fourier transform of the first function times the Fourier transform of the second function. Okay? So this is the Fourier transform. Which one is important here? So this one, that one. Oh, the complex signal frequency translation, similar to the cosine one, but just if you multiply WT times E, AWT, the Fourier transform is, and this is constant here, the constant frequency. Fourier transform is WF minus FC. Meaning, this is cosine WCT plus A sine WCT. That's that. This one as well, we use this one today, the derivative. And
which one is that one you put in cosine? Cosine WCT plus. Oh, that is.
No, this is this.
That is that one. Oh, yeah, that's that. Yeah.
So let's look at this problem. And here's problem 219. You have this function. So this is minus 2. Minus 1. So you got this, that, goes down here. This is minus 2, this is minus 1, 1 and 2, 4 up here, and 2 here. So the question is to find the Fourier transform of that.
are 2 and 4. On
2
the-
and 4,
on
yeah.
the WT. Yeah.
And -2, -1, 2, 1 and 2. So the easiest way here is to realize that this is actually two rectangular poles right here. So we have one that is actually let's call it W1T. It's a pulse with amplitude 4 and duration 4, right? That's one. And then we have another one with amplitude 2. Oh, sorry, it's 4. And duration 2. Right? But what you have here is one minus the other. Right? So if you have a pulse like this, with amplitude 4 and duration 4, this is right, and you have another one with amplitude 2 and duration 2, right? If you subtract one from the other, you will get that, right? Yeah. So this, you will have 4 in this minus 1 to 1 segment. You have 4 minus 2, which is 2, and then the rest you have 4 minus 0, and that's it. Yeah. So that function is actually this pulse minus the other pulse, right? So if you apply the Fourier transform of the first one, remembering that this is Fourier transform, but rectangular pulse, and both of them are centered at 0, right? So there is no delay here. It is duration, amplitude, sync of by FT, right? So for this one, the Fourier transform is amplitude times duration, which is 16, right? Sync of pi f, duration, which is 4. And the other one is 4 sin of YF2. Right? So as homework from Tuesday, Wednesday, is to get this result, right, by using the first derivative of that function. Okay. So get this, but by using the first derivative theorem. Which says this.
Find WF using the first derivative.
Huh?
Find WF using the first derivative.
What?
Finding WF using the first derivative.
Find what?
WF using the first
Yeah.
derivative.
So get this, which is WF, right? But taking the first derivative of this, finding the Fourier transform of the first derivative, and then go back to the original one.
Like we did in the other problem.
Yeah, exactly. Yeah. So first derivative here, W prime, Fourier transform of this first derivative, and then back to the Fourier transform of this function, which should be this same, right? So first derivative here, Fourier transform of the first derivative, get this and go back to WF. Yeah. So I
Okay.
see you in a week.
All right.